Do you want to know how computer vision applications shape the future of our modern cities? Welcome to the series of 50 computer vision applications for smart cities, where we will overview different computer vision applications that are possible on a current level of technology and see the building blocks that are necessary to implement them. Without further ado, let's review our first 5 basic applications of computer vision for smart cities. The first one is the main application for traffic management, which is a simple traffic count. Our task consists of understanding what kind of vehicles we can see through our camera and counting every vehicle that passed through a particular trajectory. Basic tasks for this use case are detection and tracking. There are a lot of extensions to this task, and many following use cases could be built on top of this task. Second use case is a parking management system, which can be formulated in a couple of different ways. First one is we build on top of traffic management system and we can detect and track all the vehicles, and then our goal is to understand if this particular vehicle was stopped in some parking area and compute the time in this parking area. The second formulation could be created as a classification problem, where we define the zone and we will try to understand if this zone is occupied by car or it is free. Third use case is a license plate recognition. In order to perform license plate recognition, we have to firstly detect a vehicle, then with another model we need to understand where we can find the license plate, which is called license plate detection, and after that we can try to recognize the characters to get the finalized license plate recognition. Fourth use case is unsafe behavior recognition, for example, detecting fighting on the streets. In order to implement this task, you can try different approaches. First one is to detect pedestrians, then to track them, to understand that you have exactly one pedestrian that you are following, and then you have possibility to classify the behavior of this pedestrian, or because unsafe behavior is usually an uncommon behavior, it could be formulated as an anomaly detection problem, which will try to separate the normal behavior of pedestrians from some anomaly behavior as fighting or falling. Fifth use case is a carpooling detection. Our goal is to understand how many people we have inside the car. This is helpful when we try to build separate lines for people who use carpooling, who has more than 3 persons per vehicle, to optimize the usage of the road and to optimize the CO2 emissions. So this is an example of a use case that could be a hardware heavy use case, because first of all we need some kind of possibility to detect and track those vehicles. Then we have to use infrared cameras to look through the windows to be able to see different persons. Additionally, we need to be able to look not only through the windshield but also on the passenger seats in order to count all the people. To ensure better performance, we need to install at least a couple of cameras to get different perspective from the car. Then, after we get infrared images, we need to train another model to detect persons on these kind of images and to count them. We briefly walked through the first 5 basic applications of computer vision for smart cities. To learn more about extracting value with computer vision applications, subscribe to this channel. If you have any particular question about one of the use cases, you can write them in the comments section or contact me through social media.